calendering. This is a process that ties all the cords together in a common bond of rubber. We can see how it works in this diagram of a 4-roll type calendering machine. As the gum-dipped material passes through the machine, a special rubber stock is fed into the rolls, here and here. Notice that only 2 rolls contact the cord. These rolls are heated to the point where rubber will cling to them. As they converge, pressing the cords between them, they apply a sheet of rubber to both sides of the material, at the same time forcing it around and between the individual cords. The calendering process is designed to make the cords strong, flexible, and durable. And now, as the processed material leaves the machine, it is rolled into cloth liners to prevent sticking. From here, it will go to bias cutting. This is the same calendared material we've just seen. As it moves across this long table, it is cut on the bias. In other words, cut diagonally across the cords. There goes the automatic knife now. Here's a better view. The cords run straight up and down. The knife slices across at an angle. As the pieces come off the cutting table, they're turned, laid end to end, and spliced into a continuous strip. A diagram close-up of what we're seeing would look like this. Here are the cords after they've been cut on the bias. Now the pieces are turned and the ends spliced together. The result is a strip of material cut to a specific width, with all the cords running in a diagonal direction. The reason for preparing the cords in just this way will be explained later. This material is now ready for tire assembly. So let's move on to the third and final section of the tire, the bead. In building the bead, only the finest high-tensile steel wire is used. At the start of the operation, 4 strands of wire are pulled from these reels, brought together, and routed through this die, which contains a special rubber stock. When they emerge on the other side, they've been covered with a thick coating of rubber. Here's what a cross-section looks like. Notice how the rubber has been squeezed around and between the separate strands. This is the building ring that winds the rubber-covered wire into a hoop, 4 plies thick. Count them. 1, 2, 3, 4. A cross-section of a hoop looks like this. 4 plies of wire with 4 strands in each ply. When the bead leaves the building ring, it's only half finished. For now it must be covered with a narrow strip of fabric called a reinforce. The reinforce ties the bead into the tire and plays a vital part in holding the tire together. And now, here's the final cross-section of the completed bead. Steel wire, rubber, and reinforcing fabric. Well, with the bead finished, we're all set. But first, a quick review. Here are the different sections of the tire as we last saw them. This is the tread and sidewall unit. This, the calendared cords. And here again is the bead. Now to put all the sections together in tire assembly. The machine used in putting the tire together is truly a mechanical marvel. It turns out a completely assembled tire in a matter of minutes. It is on this collapsible drum that the tire is actually assembled. The first step, however, is to place the beads in position, right and left. Then a touch of cement is applied to the drum, and it's ready to receive the first ply of cord. Now this is to be a 4-ply tire, so eventually 4 layers of this material will be put on the drum. Now remember, we were going to find out why the cords were cut on the bias. Well, as soon as the operator has 2 plies in position, We'll try to unravel the mystery. There. He's made the splice on the second ply. Now, let's see what it's all about. Here's a diagram of the first ply, with the cord angle running in this direction. That means that the first ply will have plenty of strength this way, and none at all this way. The second ply, however, has its cord angle reversed, like this. Thus, when the two plies are used together, they produce equal strength in all directions. Now, in the steps that follow, these two plies will be turned down over the edge of the drum, like this. Then the bead is placed in position, and the plies are turned up and over the bead and secured in place. When the third and fourth plies come on, they double the strength all around. These two plies are turned down and under the bead and fixed in place. Now let's watch the entire operation as it actually happens. With the drum in motion, the plies are pressed down to receive the bead. Then a stitching tool is used to fix the bead reinforcements in place. Finally, the first and second plies are turned back over the beads. Now, let's watch the placing of the third and fourth plies. Here's number 3. And here comes number 4. It's time now to add the chafers. These narrow strips of fabric help prevent chafing where the tire contacts the rim of the wheel. Of course, strength is needed most in the very center of the tire. So, to bolster this area, 2 extra layers of safety lock gum dip cords are added. Ready now for the tread and sidewall unit. And it's handled in just the same way as the other sections. After the tread is fixed in place, the operator identifies his work by attaching a sticker bearing his number. Automatic stitching comes next. As these stitching wheels apply pressure to the tire, they force air from between the different layers and lock all the sections firmly together. And now here's the final step in tire assembly, turning the third and fourth plies under the bead and stitching them in place. The job is done. Yes, this is a tire, though you can hardly tell it from the shape it's in. However, it's already on its way to have a beauty treatment. So let's see what happens in bagging and shaping. This is the machine that takes the flat hoop of rubber and fabric and shapes it into something that begins to look like a tire. There. That does look more familiar, doesn't it? To start this operation, a shaping bag is used. It's connected to an air hose and drawn up inside the press. In X-ray, we'd see the bag in this position. When the tire is put in place, the press begins to move down. Air is forced through the press and into the tire. At the same time, the bag fills with air too, and the tire is formed. However, this is still a green tire, and it must be vulcanized or cured. Well, that's the next step. Here in the curing room are long rows of jacket molds. These molds supply the heat and pressure necessary for curing the tire and welding all parts into a single unit. This is Firestone's safety-assured construction, which provides extra strength and longer tire life. And they also mold in the tread design, the name, and other identification marks. The molds are never idle. As soon as one tire is finished, another is ready to take its place. And now, with this green tire set up and ready to go, we're going to watch the curing process from start to finish. Actually, the curing time for this type of tire takes 41 minutes. But for our purpose, we're going to speed it up. We're looking at a cross-section of the green tire and the mold. Notice that the shaping bag is still in the tire. But instead of air, live steam is now injected into the bag. At the same time, the mold itself begins to heat. Of course, these temperatures are rigidly controlled. And as they approach their peak, the tire becomes soft and pliable. Inside pressure from the bag forces the rubber in and around the tread pattern. And this forms the famous Firestone tread design, which protects against skidding and provides extra traction. Now, as soon as the specified time has elapsed, the curing operation is complete. After the tire leaves the jacket mold, the curing bag is removed and will be used again. Well, there goes the finished tire. It's on its way to final inspection. Every tire in the factory must eventually pass through this department. And incidentally, all these different tires have been built using the same basic processes. Ah, here's our tire up for inspection now. All the work and effort we've seen is now being put to the test. And the inspector misses nothing. This tire is okay. And so are hundreds and thousands and tens of thousands of others. For these tires have been built with skill and care, from the gathering of the raw materials through all the operations and processes at the factory. Today, it may be truly said, the modern tire is a modern miracle, bringing speed and comfort and convenience to civilized people around the world. For today, the world rolls on tires, and you can always depend on Firestone for the best today, still better tomorrow.